In the video that explains the big O n complexity, we've seen that an algorithm has a linear time complexity if it eventually always performs less than or equal to a constant times n number of operations. Here is an overview of what is covered in the big O n explain video, which I will link in the description, and I encourage you to watch it if you haven't already done so. In this video, we'll go through 5 exercises to help you master big O n. Before we start, here's how it's going to work. I'll pose a problem, show you some code, or ask a question. I'll then give you a few moments to think. I encourage you to pause the video at this point, because next I will give you a hint. You should stop the video again, see if the hint changed your thinking in any way. I'll then reveal the answer and give you an explanation. So let's begin. You are given an unsorted array. Your task is to find the smallest element. What is the worst case complexity and why? Pause the video before the hint. Okay, I want to point out that the array is not sorted, so the smallest number could be anywhere. In this case, how many elements do we have to check to find the smallest one? The complexity of an algorithm that finds the smallest element in an unsorted array is big O n, because we have to iterate through all the elements to find the value. Even if the minimum element is found on the first position of the array, we won't know that it is indeed the minimum until we compare it with all other elements of the array. The next problem asks you to insert an element inside an array. What I mean by inserting is not changing one of the values, but actually placing a new element in between two pre-existing elements. Pause the video before the hint. You might already know this, but the length of an array is set in stone when the array is defined. I know that there are programming languages that have vectors or lists that can grow dynamically, but what we understand by an array is a sequence of fixed length. With this information in mind, how would you go about inserting an element in between two pre-existing elements? The answer is that we have to create a new array of length n plus 1. Copy over the elements before your desired position, insert the new element, then copy over the remaining values. Because we have to iterate through the whole array and copy over the values, the complexity of this approach is linear, big O n. The next problem asks you to determine if a given number is present in a sorted array. For example, 24 is not found in this array, so we return false, but 103 is, so we return true. Can you think of a big O n approach to solve this problem? There will be no hint this time, we'll jump straight to the answer, but pause the video and have a think. Okay, the naive solution is to go through the elements one by one and stop either when we find the value we are looking for, or if the numbers being examined are beginning to be larger than it. In the worst case, we have to iterate through the whole array, which gives us a big O n complexity. But notice that the array is sorted. Can you think of a better approach to find a value in fewer than n steps? Drop a comment with your idea and I will give you a like if your solution uses fewer than n steps. In this problem, you are given a for loop that executes some constant time instructions. Is the complexity of this loop big O n or not? Pause the video before the hint. I'd like to point out that the next step stage of the loop is not quite standard. The iterator variable I doubles every time. In fact, let me show you visually the effect this has on an array. Notice how the jumps are getting bigger and bigger. With this information in mind, is the complexity of the loop big O n or not? The answer might surprise you, but technically we can indeed say that the for loop executes in big O n time. Before you tell me that I'm wrong, hear me out. The for loop executes a number of log n steps. This is something we explain in more detail in the big O log n video. The thing to keep in mind is that the big O notation specifies an upper bound. If an algorithm is growing no faster than a logarithmic function, log n, then it also means that it's growing no faster than a linear function, big O n, nor growing any faster than a quadratic function, big O n squared, etc. The for loop that we saw earlier has a big O log n complexity, but technically it also has a big O n complexity and even a big O n squared complexity. These are all true statements. In practice, we tend to always specify the tightest upper bound, which for the previous loop, it was big O log n complexity. In the final exercise, we are analyzing this function which takes a string and determines if the string is a palindrome. A palindrome is a sequence that reads the same backwards as forwards. For example, step on no pets is a palindrome because backwards the string is still step on no pets. What's the complexity of this code? Pause before the hint. The key is determining how many times the for loop is being executed. With this in mind, what's the complexity of this function? Okay, the for loop goes through the whole string, so the complexity is big O n, where n is the length of the input string. As an extra exercise, I haven't optimized this function on purpose. Use the comments area to answer two questions. Firstly, how would you improve the code to perform fewer operations? And two, would the complexity of the algorithm change in any way? Use the comments to share your ideas.